I'm Julius Smith. I'm here at the Center for Computer Research in Music and Acoustics, CARMA, and I teach music signal processing, audio signal processing to graduate students in music, electrical engineering, computer science, and other departments. And we're all working toward interesting problems in music technology. So signals are things that convey information, sensor data, things that people say, things that people make, sounds that people make. And so those sounds get recorded and processed, and we call that signal processing. So, any kind of recording studio operation is going to do a lot of signal processing. And then when the computer came along, we went to the digital form of that, and that's called digital signal processing. So things like filters become implemented numerically instead of using capacitors and inductors. We digitize the signal, as you know, sampling, and then we process those samples as numbers. Just about everything we do in electronic communication or entertainment or monitoring of physical quantities like temperature, motion, forces, it involves digital processing of audio, video, sensory data, sensor data. Our GPS is a signal processing system, and so on. We make extensive use of signal processing in our music software, our digital audio workstations, and the plugins that go into those, television and movie production tools. It's ubiquitous in our field. For example, we use graphic and parametric equalizers for audio for adjusting gains in the various audio bands. We use dynamic range compression when we record and when we master CDs and so on. We compress audio and decompress it. You've probably heard of MP3 and AAC formats. Those are, perceptual audio coding formats that we use, and that's very intensive signal processing. If you have a pair of noise-canceling headphones, there's good signal processing going on in there. We use software synth plugins, audio effects. We have phasing, flanging, chorus effects, echo, reverb. So it's a very widespread set of applications. You even need fancy signal processing just to play a sound file from one computer on another if the sampling rates are different. So our Linux machines tend to use 48 kilohertz sampling rate, while the Mac uses 44.1. So converting that sampling rate is a pretty heavy-duty signal processing task all by itself.
Silent, but we're often presented to the public while a piano